All right, so welcome to this video. In this particular video, we'll be discussing the idea and the concept of discontinuities. So there are essentially two types of discontinuities. So this is where a function is not continuous. And what I'll start by defining the types of discontinuities, and then we will go through the diagrams to see which diagrams represent the discontinuities. And then we shall then come back to and do an example. So let us start with this. So when a function is not continuous, so we have what we call a discontinuity there. So for example, in this case, if we're talking about a discontinuity at x equals to a, the first type we've got is a removable discontinuity. So basically what this means is that simply the limit of f of x as x tends to a, both from the left and the right, is not equals to the function where a is. So basically, if you've got the situations, then this is not true. But remember, it's important that the limit exists. So you will see that the limit exists, but what happens is that the statement is not true. So therefore, you have what we call a removable discontinuity. The second type we've got is one that's called a jump discontinuity. All of this is happening at x is equals to a. So basically, a jump discontinuity occurs where the limit as x tends to a of f of x does not exist. Okay, so basically wherever you have this particular limit not existing, that's when you'll have a jump discontinuity. Remember here, the limit has to exist. So once the limit exists, but the limit is not equal to the function at a, then we say that we've got a removable discontinuities. So those are the two types of discontinuities. Now let's look at the graph. So we'll look at this first one over here. So in this particular case, you will see that if you are approaching, let's deal with 1. If you're approaching from the left and you're approaching from the right, you'll see that a limit will exist, but there will be no value for 1. So here we will have what we call a removable discontinuity. So I'll just write it as RD over there. Now let's look at the next one here. So let us pick 3. So if we're looking at 3 as a critical value again, you will see that if you're approaching 3 from the left, you'll get a negative number there, whatever the number is. But if you're approaching 3 from the right, you will get another number over there. So you can clearly see that the left limit and the right limit will not exist. So the limit will not exist. We call this a jump discontinuity. That's just a good way of seeing it up. Similarly, if we look at this function now, we're looking at 5. We can clearly see that if you're approaching 5 from the left and you're approaching 5 from the right, you will get to some value, whatever the value is. But you can see that at that value, it does not exist because f of that function is given by this closed function over there. So here, we will then come back and have a removable discontinuity because the limit does exist. It's just that f of a is not the same as that. So the diagrams are indicating this quite nicely. So similarly here, if we're taking the function at 2, approaching it from the left and right, a limit does exist, but now it's just not the same. So f of 2 will not be the same. So therefore, we have a removable discontinuity. If we look at this function over here as the third one, if you're approaching 0, like the function does not exist where 0 is, you can clearly see that it will be undefined. So we say that the limit does not exist, and hence we've got a jump discontinuity. Again, if we look at this function here, this fourth one, if you're approaching 2 from the left and right, there is a limit that exists, but f of 2 is not the same because this is an open function, this is a closed function. We then have ourselves a jump discontinuity. I hope this is making some sense, so let us close it off with a good example. Okay, discuss the discontinuity for this particular function. So what we'll do, we'll check if the limit exists first. So we'll take the limit as x tends to 2 from the left. So if we turn it from 2 from the left, we will bump into this equation first. So let's simplify the limit now. We'll go 2 times 2 minus 4, giving us 0. Okay, now let us try the limit from the right. So we'll go the limit as x tends to 2 from the right. We'll see we bump into this equation there, and therefore this becomes, we substitute 2 squared minus 4 is equaling to 0. Oh, so the limit does exist, is equals to 0. Last step, let's check what f of 2 is. F of 2 is equals to 2. So therefore, in this case, we can say that the limit is x tends to a. So the limit does exist, but it is not equals to f of 2. So if that is the case, the limit existing, we have what we call a removable discontinuity. I hope this has made sense. And therefore, if this has made sense, I shall then see you in the next video. Discontinuity. Okay, see you in the next video.